In the mountains of northern Chile, the Vera Rubin Observatory photographed something 9 times before anyone knew it was there. It had come from another star, and for the first time in history, somebody knew exactly what to look for. The observatory sits on a ridge called Cerro Pacan, and in the early summer of 2026, it began the Legacy Survey of Space and Time, a 10-year sweep of the southern sky. Its camera holds 3,200 megapixels, the largest digital camera ever built, and it rephotographs the whole visible sky every few nights across 6 colors of light. What it is built to catch, among many other things, is rare in the most literal sense. The 3 we know of are Oumuamua, spotted in 2017, the comet Borisov in 2019, and an object catalogued as 3I Atlas in the summer of 2025. Each betrayed its origin the same way, by moving too fast on too open a path for the sun to have ever held it. 3 in a century, and now a camera that never blinks. Keep watching, because this is not a story about a promise. The rules for that test were written down before the next visitor arrived, and then they were aimed at a real one for the first time. Subscribe, and you will see exactly what they were looking for. Go back to the first one, because Oumuamua still sets the terms of the argument. Robert Wyrick found it with the Pan-STARRS telescope in Hawaii on the 19th of October 2017, roughly 40 days after it had already whipped around the sun and started back out. We had a matter of weeks to look at it before it faded for good. In that short window, it did 2 things nothing in our own solar system does. As it receded, it sped up by more than the sun's gravity alone can account for, and yet no comet tail, no coma, no trace of dust was ever seen escaping it, and no proposed cause has since been confirmed. It was also stretched to an extreme, as much as 10 times longer than it was wide, tumbling end over end about every 8.5 hours. We never learned what it was. Here is what that single object did to the arithmetic. Before 2017, the careful forecasts from Morrow Martin, from Turner and Loeb, from Engelhardt and colleagues, held that a decade of surveying would most likely turn up no interstellar visitor at all. They were rare to the point of being almost hypothetical. Then one arrived, and finding even one, in the small patch of sky we happened to be watching, meant the space around us had to be far more crowded than anyone believed. The estimated number of these objects drifting between the stars jumped by roughly a factor of 1 million. They were not freak events. They had been streaming past us the whole time, unseen, and that raised a question no one had a clean way to answer. Could one of them be built? This was never settled science, it was a public fight. Avi Loeb, at Harvard, argued that Oumuamua's strange behavior was consistent with a thin artificial sail pushed by sunlight, a claim he laid out with Bialy in 2018, and he made the same argument again for 3I Atlas years later. Most of his colleagues pushed back hard. The astrophysicist Paul Sutter and the international team assembled to study Oumuamua openly questioned the idea and held that everything about it, however odd, still fell within the range of natural objects. The trouble was that both sides were reasoning after the fact, on an object already gone. There was no agreed test, nothing written down in advance that could confirm what would even count as evidence of manufacture. That is what changed in 2025. A team of astronomers wrote out, before the next visitor arrived, a concrete procedure for checking any interstellar object for signs of technology. The paper, titled Techno-Signature Searches of Interstellar Objects and submitted in August of that year, carries a long author list, including Davenport, Shake, Croft, Wright, Lintott, Seligman, and Andrews Simeon. It names 4 things to look for. First, a path that bends the wrong way, a push or a maneuver that gravity cannot explain. Second, colors that no natural surface should show, together with waste heat glowing in the infrared. Third, a shape read from the way the object's brightness rises and falls as it spins, something like a cylinder that you do not find among natural asteroids. And fourth, the most direct sign of all, any transmitted signal, in radio or in light. What lifts this above a thought experiment is who helped write it. Andrew Simeon runs Breakthrough Listen, the largest search for alien signals ever mounted, and the authors were blunt about the intent. Because Rubin will start finding these visitors routinely, the check should run on every single one. As standard practice, not be improvised after the object is already leaving. Picture the shift they were preparing for. Instead of 3 visitors in a century, Rubin is expected to turn up a steady stream. The estimates vary honestly and widely, from about 15 across the 10-year survey to as many as several dozen in a single busy year, depending on how small an object you assume you can catch. The stream may already have started. The object behind those 9 early frames was announced on the 1st of July 2025 as 3I/Atlas, and by then Rubin had been quietly collecting it for a week and a half, with nobody having flagged it as a discovery at all. Colin Orion Chandler and his collaborators used those images to pin down its orbit and its coma, and that became the first scientific paper ever drawn from Rubin data. So the test finally had a real subject. When 3I Atlas finally came within range, Breakthrough Listen pointed the Green Bank telescope at it across a wide band of radio frequencies, reaching for any narrowband transmission down to about 1/10 of a watt, which by interstellar standards is a whisper. The SETI Institute's Allen Telescope Array listened alongside it. Consider what that meant. For the first time, a visitor from another star was not argued over after it had gone. It was measured while it was still here, against rules agreed on in advance, by the largest search for alien signals ever mounted. Every object of this kind before it had been debated in hindsight, from photographs and orbits, long after the chance to look had closed. And the reason to build all of this now is a hard limit we keep running into. Every visitor so far has been spotted too late. Oumuamua was already 40 days past the Sun and outbound. 3I Atlas passed closest to the Sun where we could not watch it from the ground. By the time we know one is here, the measurements that would matter most are often already out of reach. Rubin does not solve that by itself, because Rubin cannot detect life or read an atmosphere. It is a wide-field optical camera. It finds objects, measures their colors, reads their shape from their changing light, and tracks their paths. And then the harder questions have to be handed to other instruments, fast, before the window closes. That is the real milestone. For as long as we had only one object at a time and no rules agreed in advance, the question of whether we are alone came down to one expert's judgment set against another's, argued over an object already vanishing. Writing the procedure down and committing to run it on every visitor Rubin finds turns that argument into something else, a measurement we make on a schedule, the same way each time, whatever it returns. So the machine on the ridge has given the argument the one thing it always lacked, a way to know. And the stream has already started. The next visitor is somewhere out beyond the planets right now, still too faint for anything we own to see, and when it arrives the check will run from the first night, the same way every time, whatever it returns. If you have a thought on which of Rubin's 4 tests should carry the most weight when it does, subscribe, drop it in the comments, and give this a like, because all 3 help it reach the people who argue about these things. Somewhere out past the planets, Oumuamua is still turning end over end, once every 8 hours or so, fading into the dark between the stars. the one we can never call back.